Okay, I'm going to go ahead and start with number 5 on page 336. We're asked to graph this function. It's already in the nice format that shows us the x value of the vertex, but if I bring the 4 over, y minus 4 is equal to a negative 2 x minus 1 squared. Now I can find that k value for the vertex. So just by looking at this right here, I know h equals 1, and here is my k value, k equal 1. Maybe I need to remind you, the general form y minus k is equal to negative 2 x minus h squared. And if I'm going to go general, let me go ahead and put an a here. That's the general form. So comparing those two, you can find h is 1, k is 4, and a is negative 2. Now h and k are simply the vertex, so I know I have a vertex at 1, 4. From looking at the a value, it's negative, so I know it's going to open down. And also from looking at the a value, I know it's going to be a vertical stretch. So it's going to be a little taller and skinnier than my parent function. And of course, the axis of symmetry, if I were asked for it, x equal 1, you always use x equals, and you always use the value of the x in the vertex right here. Alright, let's go ahead and graph it. I have a vertex at 1, 4. I know I'm going to open down with a vertical stretch. Now I'd like to get one more point at least on this graph to help me just really understand how much that vertical stretch is affecting it. So I think I'm going to go ahead. It's easy to find a y-intercept. A y-intercept is when x equals 0. We do this all the time. So in my case, y is equal to 4 minus 2 times 0 minus 1 squared. So that's going to come out to y equals 4 minus 2, or just y equal 2. So I have a y-intercept of 0, 2. So let me put that on my graph. And that gives me an idea of how much my vertical stretch actually looks like. Now if I wanted to go further, I could find those x-intercepts as well, but I'll leave that for another time. Okay, I want to go ahead and graph number 9 for you. The problem is I can't easily tell what the vertex is when a quadratic is in this form, same as we would use quad formula for. It's not in that parabola form. So we're going to have to complete the square to get it into that nice parabola form. And I've got a leading 2 to deal with. So here we go. First thing we're going to do is factor out the leading 2, but only from those first 2 terms, any term with an x in it. And here we'll add the plus box. Here I still have plus 1 on the outside, and because I'm going to add in the plus box on the left, and I want to stay, I added plus 1 here on the right side of the equation, I have to have a minus box over here because they're on the same side of the equation. If I add a box, I have to subtract a box in order to not change the equation. And because this first box was inside the parentheses, it's already being multiplied by 2. So this one has to also be multiplied by 2. At this point, it looks just like completing the square did before we had this extra complication. So now go ahead and do what you remember doing before. So this becomes x minus 1, because half of this 2 is 1, so that goes here and here. Multiplying these together, I get plus 1, so those had to be in the box here, so I'll put it in the box here. So now I have plus 1 minus 2 when I multiplied these two things together. Alright, let's write this as 2 x minus 1 squared minus 1. So I wrote this multiplication as a perfect square, and I added these two numbers together. So now you're looking at a function that's in the parabola form. I can easily see the vertex is at 1, you know what? I'm going to back up just a minute. We like to, in this class, use y instead of f of x, and we like to have that minus 1 move over to this side. Plus 1 is equal to 2x minus 1 squared. Let me write this really explicit. My y minus a negative 1 is equal to x minus 1, and that's going to help us see while h is 1 for my vertex, the k is a negative 1. So there's my vertex. I know it's going to open up because the a is 2, which is positive, and I know it's going to be a vertical stretch because the a is greater than 1. I don't know exactly how much yet, but I can go ahead and graph it now. Okay, so here's where I was. I know where my vertex is. It's at 1 and negative 1, so right here. I know it's going to open up. I'd like to nail a point so know exactly how tall and skinny this really is. So let me find that y-intercept when x equals 0. So y plus 1 is equal to 2 negative 1 squared. Y plus 1 is equal to 2. Y is equal to 1. Okay, so I have a y-intercept right here. So I know things are symmetrical across this axis of symmetry, x equal 1, because it's the same right here. So I think I'm going to go ahead and mark the symmetric place. If this point is 0, 1, and I'm 1 away from this axis of symmetry here, and if I go 1 more in this direction, I'm at x equal 2, but I'll still be here at y equal 1. So 2, 1 is a third point I can have on my curve. I could come down through the vertex in a smooth curve and back up. And indeed, it opens up. Okay, I'll do one more like this. Number 17, we're asked to graph a parabola. It's not in the parabola form, so I'll need to complete the square. But I don't have that leading 1, so things get a little complicated. And this time it's a fraction, which actually I think I'm going to like better. If I pull the 1/2 out, obviously this first one is left with x squared, but watch what happens here. This one, if I take the 1/2 out, is left with 2x. Now, how'd I get that? Well, better question is go ahead and check it and see if that really did work. Could I go 1/2 times 2x and get the 1x I need up here? And the answer is yes. So I must have done it right. Factoring out 1/2 is like dividing by a half, and dividing by half is the same as multiplying by 2. So that's how we get there. But always you can go back and check this. But now that I've done that, remember I don't factor the 1/2 out of this number. Leave it alone. It's going to stick out to the right-hand side. So just go ahead and add your box. Close the parentheses. Now we can add in the plus 1/2. And now we can subtract the 1/2 box. It's subtraction this time for the box because the boxes are on the same side of the equation. One's a plus, one's a minus. I need the 1/2 because this box is already being multiplied by 1/2, so the second box has to as well. Alright, so let's go ahead and finish the complete the square. The 1/2 just stays out front, hangs out for a while. X, what's half of this 2? 1. So that's what goes here and here. But now multiply these two 1's together, you get 1 for this box, so put a 1 in that box. So now I have plus 1/2 minus 1/2. Aha! So in the end I have my g of x, which I'm going to go ahead and call it y. It's 1/2 x plus 1 squared plus 0. So there's no vertical shift at all to this one. Okay, so I'll make it easy. Basically I've got y minus 0 here to help us find the vertex, make it perfectly clear for you. I could also, to make it even clearer, call this x minus a negative 1 squared, because we're always asking x minus h. So here I can see the vertex, which is normally given by h and k, would be a negative 1 comma 0 for a vertex. That makes your axis of symmetry x equal minus 1. The A is equal to a half, so you know it opens up, and you know it's going to be a vertical shrink in the end. So let me go ahead and erase some of this. Maybe I can fit this graph on the same page. Alright, I got a vertex at -1, 0, right there. My axis of symmetry going right down through that vertex. I'd like to find the y-intercept when x equals 0. So y is equal to 1/2 0 plus 1 squared, so y is just a half. So a y-intercept is at 0, a half. So let me put that on here. Right about there is 1. So I'm going to have a second additional point right there at -2 1/2, because this was 1 unit away from the axis of symmetry, this is 1 unit away from the axis of symmetry, so they will be symmetric points. They'll both be 1/2. And then I can draw a nice smooth curve between those 3 points I found. Okay, here's a different kind of problem. They're asking for a maximum or minimum value of the function. Okay, and then we'll find the vertex. So rather than complete the square, we have a little trick here, because the vertex will be either the minimum or maximum. And I know that's going to happen. Maximums or minimums always happen at x equal minus b over 2a. Now a and b are referring to the exact same thing they refer to when you're doing quadratic formula. So when you have an equation that looks in this format, the quad formula kind of form of it, and you want to find a vertex or a min or a max, let's use this trick. It'll be a little easier than completing the square sometimes. So in my case, a is equal to 2, b is equal to -6, and I don't even need c. So I'm just going to go ahead and find the x value when we're at the min or max, or when we're at the vertex. That's going to be minus a -6, so plus 6, over 2 times a, which is 2 times 2, 4. So x is equal to 3/2 if I reduce it. That's the x value of the vertex. Now we have to find the y value of the vertex, but that's finding g of 3/2. Because remember, that's just like finding y. So 2, 3/2 squared, minus 6 times 3/2, plus 2 will find us that y value. Two times 9 over 4 minus, well, just go ahead and call that 9 over 1 plus 2. So that's going to equal, let me reduce this, 9/2 minus 7, 9/2 minus 14/2. I'm getting y equals, oh yeah, minus 5/2. There's my y value of the vertex. Now, the question would be, is this a minimum or is this a maximum? And the answer to that lies right here, or the value of a, because a is positive, okay? You know this is an open up parabola, so this vertex is a minimum, okay? So what we're going to say is we have a minimum at the point x first, 3/2, comma, y comes next, minus 5/2. And that's the position of the vertex, and the value of the function at this is the y value. So we're finding y equal -5/2 is the maximum, or I'm sorry, the minimum value. Okay, here's a question, number 25. It's a nice quadratic. They're asking for the vertex, the domain, the range, and the zeros. Now there's two ways I could find the vertex. I could complete the square. It's not a bad problem for that. That wouldn't be hard. I could use x equal minus b over 2a, so it's sort of my choice which way I want to go. I think first I'll try it using x equals minus b over 2a when you're at the vertex. So my x will equal 4 for negative b over 2, or x is equal to 2. So I found the x value at the vertex. The y value is going to be 2 squared minus 4 times 2 minus 3. Just evaluating the function at x equal 2. So y is equal to 4 minus 8 minus 3. Y is equal to negative 7. So I have a vertex 2 comma negative 7. So that's the first part. Got it. Hey, Austin. Then, to understand domain, that's always going to be easy. The domain of all quadratics is all real numbers, but the range. The range is going to depend on whether or not this vertex is a minimum or a maximum. This one, if you look here, is a positive coefficient, so it's opening up, okay? So open up means that this vertex is a minimum, which means the range will range from the minimum up to positive infinity. So our minimum value of y is negative 7 to infinity, then will be the range. And it can't equal negative 7, so I have to put a square bracket. Then I have to find the zeros. Well, that's when 0 is equal to x squared minus 4x minus 3. And I have to go through my little checklist of what method to use. Does it factor? Oh, very tempting, but not quite. So I'll go ahead and use quad formula. X equal 4 plus or minus the square root 16 minus 4. A is 1, C is negative 3. All over 2a. Oops, of course a is 1, so that can go away. Okay, so here I am still trying to find the zeros of this function. I'm using quad formula. I've got to simplify this. 4 plus or minus the square root of 16 plus 12. Two negatives make a positive, all over 2. X is equal to 4 plus or minus the square root of 28, all over 2. I've got to figure out now how to simplify the square root of 28. Please do not start canceling top and bottom yet. X equal 4 plus or minus the square root. 28 is 4 times 7. So that's going to help me reduce that. 4 plus or minus 2 square roots of 7 all over 2. Now here's where I can start canceling out the 2 in the bottom, but I have to make sure I do both terms on the top. That leaves the 1, that leaves the 2, that leaves a 1. So I'm left with x equal 2 plus or minus the square root of 7 over 1 isn't necessary. Those are my zeros of the function. Another word would be x-intercepts. They would be the solutions to y equals 0 and all that good stuff.